ఇంటర్మీడియట్ విద్యారంగంలో అగ్రగామి మన NSR ఇంపల్స్ ఎడ్యుకేషన్ ఇన్స్టిట్యూషన్. ఐఐటి జేఈఈ అయినా నీట్ అయినా తిరుగులేని విద్యా సంస్థ NSR ఇంపల్స్.
We have completed reaction with metals. Next, reaction with non-metals. Sorry, we have completed with metals. Reaction with inert gas. So what are inert gas? Zero group elements. So xenon, krypton, they react with fluorine to form different compounds. It can be XeF2, it can be XeF4. That depends upon the concentration. Or xenon hexafluoride. These are the different fluorides of xenon. Depending upon the in what ratio they are allowed to react, you will may get difluoride, tetrafluoride or hexafluoride. Next, oxidizing properties. Oxidizing properties of fluorine. So here fluorine is allowed to react with some compounds. So let us see the first one. Potassium bisulfate plus F2. Here fluorine acts as oxidizing agent. It itself will undergo reduction, right? So potassium bisulfate is converted into persulfate, K2S2OH plus HF. So 2HF. Sulfate, sulfur is converted into persulfate, peroxide disulfate. H2S2O8, it is the salt of H2S2O8, Marshall's acid. So fluorine oxidation state changes from 0 to -1. The next one is KClO3, perchlorate reacts with fluorine in presence of water. Already we have studied the reaction with H2O and F2. What we get is oxygen, right? If I write H2O and F2, you will get 2HF plus nascent oxygen. So like this here, H2O plus F2, 2HF plus nascent oxygen. This nascent oxygen is added to KClO3. KClO3 plus nascent oxygen is, what we will get is KClO4. We will get KClO4. Addition of oxygen, nothing but oxidation. So KClO3 is oxidized. You can see the number of oxygen atoms here, there are 3, here there are 4. Addition of oxygen is nothing but oxidation. So what is the oxidizing agent? F2. So let us assign the oxidation state for fluorine. This is 0. Here what we get is -1. So here in KClO3 the oxidation state of chlorine is +5. Here you will get +6. So you know how to calculate. K plus ClO3 minus K plus ClO3 minus oxygen carries -2, 3 into -2 -6. There is a net negative charge. So the oxidation state of chlorine should be +5. When I come to KClO4, K plus ClO4 minus 4 into -2 -8, there is a net negative charge, so it should be +7. So it changes from +5 to +7, right? Similarly, you can oxidize iodide also, chlorate iodide, KiO3 plus water, similar type of reaction, right? Nascent oxygen is added to this, resulting in the formation of periodate KiO4. So same process, 0 to -1 reduction, therefore it is oxidizing agent. Number of oxygen changes from 3 to 4. Addition of oxygen is oxidation. So we have one more, that is H2S. So can you guess the products here? Right, H2, F2 gives HF. Will I get S? The answer is no. When there is sulfur, the sulfur exposed to fluorine, what I will get is SF6. The reaction cannot be stopped till you get hexafluoride. So always you will get SF6. Sulfur oxidation state -2 2 plus 6, -2 2 plus 6. Fluorine oxidation state 0 to -1. Of course, here also you will get -1. Hydrogen, no change. Next, reaction with ammonia. Reaction with ammonia. So it is interesting and it's very important. Ammonia reacts with fluorine under two conditions. So if ammonia is present in less quantity or fluorine is present in more quantity, if fluorine is in excess, then fluorine, since it is present in excess, it oxidizes nitrogen to maximum possible oxidation state here, that is NF3, and HF, anyway you will get HF. So we have to balance this. You have 3 nitrogens, so 3 HF, 3 plus 3, 6. If ammonia is present in excess, then all the nitrogen cannot be oxidized. This is present in less quantity, so it will be converted into HF. Now, how to remember this? Is it balanced? Yes. NF3. That. First, let us assign the oxidation state, then we will see. What is the oxidation state of nitrogen here? It is -3. Now here it is +3. Right. What is the oxidation state of nitrogen? Here it is -3. Here it is 0. Coming to fluorine, this is 0, -1, 0. Right. Anyway, it is -1. Now, if ammonia combines with excess of fluorine, we have excess of fluorine, you will get nitrogen. That nitrogen can be further oxidized, -3 to 0, 0 to +3. Therefore, the change in the oxidation state is high. So, when ammonia reacts with excess fluorine, nitrogen is oxidized to higher oxidation state, resulting in the formation of NF3. If excess ammonia reacts with fluorine, fluorine is present in less amount, therefore it will be oxidized to not to higher oxidation state, but an intermediate oxidation state of 0. So when ammonia reacts with excess fluorine, you will get NF3. When excess ammonia reacts with fluorine, you will get N2. That is how you have to remember. Next, reaction with hydrocarbon. Reaction with hydrocarbons. Let us take methane reacts with fluorine. Depending upon the amount, you may get one hydrogen may be replaced. So you will get a mixture of products, or 2 hydrogens may be replaced, or 3 hydrogens may be replaced, or all the hydrogens may be replaced. One more important reaction is with methyl alcohol. All the hydrogens in the methyl alcohol are replaced here. So if I replace all the hydrogens, what I will get? CF3OF and this one. So this is what? This is powerful oxidizing agent. You have more fluorines, very powerful oxidizing agent. Oxidizing agent. So these are the chemical reactions of fluorine. Now let us study some important uses of fluorine. Uses of fluorine. Fluorine is used as rocket fuel because most of its reactions are spontaneous, so it is used as rocket fuel. Used in the preparation of important compounds like NaF, AlF3 and compounds like Teflon, CF2CF2, C2F4 Teflon, tetrafluoroethylene. Teflon is used as a insulator, right, while doing organic reaction in the lab. Teflon coating is also done for, in the making of non-sticking pans. SF6, a compound of fluorine. It is used in high voltage equipment like transformers as gas insulator, high voltage instruments, equipment or instruments. The gas that is used in transformers, high voltage equipment, is SF6 because it is stable even up to 500 degree Celsius. So you might have studied the reason for that. Next, chlorofluorocarbons are used in refrigerators, because of which ozone depletion takes place, but in refrigerators they are used chlorofluorocarbon, a compound of fluorine. And HF, a compound of fluorine, is used for etching of glass. So what happens? Glass is nothing but silicate. It contains SiO2. When it comes in contact with HF, remove hydrogens as water, right? So 4HF, I will get SiF4 plus 2H2O. The SiF4 further reacts with HF to form hydrofluorosilicic acid, that is H2SiF6. So HF, a compound of fluorine, is used in etching of glass. Glass contains silica and this reaction takes place, resulting in the formation of hydrofluorosilicic acid. So this is about fluorine. So the next element is chlorine. Chlorine was also first discovered by Scheele. Chlorine is also reactive, therefore it also exists in combined state. Right. So let us study the important minerals of chlorine. The first one is carnallite. KCl MgCl2.6H2O. Horn silver AgCl. Sylvine, KCl. These are the important minerals from which chlorine can be isolated. Now let us study the preparation methods. So what happens here? Chlorine mostly exists in combined state because of high reactivity. In combined state, if I take any of its minerals or salts, it is present as Cl minus. Our aim is to convert it into Cl2. That means we have to remove 2 electrons. So Cl minus, that is minus 1 to 0. That means Cl minus should be oxidized. See follow the change in the oxidation state, minus 1 to 0, the oxidation number is increasing, therefore Cl minus is undergoing oxidation. The oxidation is carried out in the presence of an oxidizing agent. So we take a substance of chloride, salt of chloride, right, and treat it with a suitable oxidizing agent. So the oxidizing agents which we are going to study here are, it can be manganese dioxide, it can be potassium permanganate, it can be potassium dichromate, it can be mild oxidizing agents like bleaching powder or sodium hypochlorite, NaOCl, right, or you can use other mild oxidizing agents like lead oxides, etc. So the salt of chloride is treated with suitable oxidizing agent to convert it into Cl2. First let us study the lab methods, then we will go for industrial methods. So each and every reaction is important. So let us study lab methods. The first one, so reaction with MnO2. So here we mostly take HCl. Manganese dioxide acts as oxidizing agent, right, it oxidizes Cl minus to Cl2. So manganese oxidation state is +4, it is an oxidizing agent, therefore it itself will undergo reduction. So the stable oxidation state of manganese lower than +4 is +2. So it will be preferably converted into +2 oxidation state and combines with the anions. The anions provider is the other solvent, that is the other reagent is HCl. So Mn +2 Cl minus, what we can expect? MnCl2. Hydrogen, it is always present in +1, it cannot be further oxidized, therefore it combines with what? Oxygen to form H2O. So we are interested here, one of the products should be chlorine. So let us balance this. There are 2 oxygens, so we can expect 2 H2O from 1 mole, 4 hydrogens, so 4 HCl, 4 chlorines, 2 plus 2, 4 chlorines. Now let us assign the oxidation states. Manganese +4, here it is +2. This is our oxidizing agent, itself has to undergo reduction. So coming to chlorine, -1 to 0. If you see, we have 4 chloride ions, 1 mole of MnO2 reacts with fluorochloride ions and convert 2 of them to 0 oxidation state. That means it can oxidize 2 chloride ions. 2 chloride ions remains as such. Out of 4 chloride ions, 2 chloride ions are only oxidized. So the next one is a reaction with potassium permanganate. So KMnO4 is a very good oxidizing agent. So before going further, KMnO4, the manganese is present in which oxidation state? +7. So it will itself reduce to +2. Stable oxidation state is of manganese is +2, that we will study in D block. So let us write the reaction. KMnO4 reacts with salt or acid like say HCl. So what happens? Potassium cannot be oxidized, it will be always present in +1, so we call it as spectator ion. Combines with opposite anions provided by the other reagent, that is chloride ion. So what we get is KCl. Manganese, it has to undergo reduction. So to which oxidation state it will undergo reduction? +2. So Mn +7 to Mn +2, +2 combines with other oppositely charged ions provided by other reagent, that is Cl minus. So what we get is MnCl2, right. Next, hydrogen combines with water, oxygen to form water, H2O. H2O. So here let us try to balance it. So if I write 2 KMnO4, I will get 2 KCl, 2 MnCl2, 8 oxygens, 2 2s are 4, 5, 6. So you get 3 H2O. Now one interesting thing is, let us try to balance oxygen. 2 into 4, 8 nascent oxygen in these 2 moles. Out of this, 3 are removed as water, left over is 5 nascent oxygen. So KMnO4 reacts with 6 moles of HCl to release 5 moles of nascent oxygen. Nascent oxygen is powerful oxidizing agent. So it combines with unreacted HCl. So very simple, hydrogen combines with oxygen to form water. How many oxygens are available? Nascent oxygens 5. So we will get 5 moles of water. That means we require 10 more hydrogen atoms. So I have to take 10 HCl. So left over is 5 Cl2. So this is the overall reaction. Add these two, what we get? 2 KMnO4 plus 16 HCl. 5 nascent oxygen, they will be cancelled. Left over is 2 KCl plus 2 MnCl2, 8 H2O and 5 moles of Cl2. Now let us come back to the equation. First I will assign the oxidation states. Chlorine, see here, -1, here it is 0. Next, manganese, here it is +7, here it is +2. Now there are 16 chloride ions. How many chloride ions? 16 chloride ions. How many chloride ions are remained as such? 2 here, here you will get 4, 2 plus 4, 6 chloride ions remains as such. Out of 16, 6 chloride ions remains as such. That means 10 chloride ions must have been reduced. 5 into 2, 10 chlorine. So out of 16 chloride ions, 10 are converted into chlorines, right? Whereas 6 chloride ions remains as such. So if I go for the next oxidizing agent, that is dichromate, potassium dichromate. So here also it reacts with HCl. What is the oxidation state of chromium? +6. Oxidation state of chromium is +6. So chromium changes from +6 to +3, +6 to +3, right? So same procedure. Potassium, no change, combines with oppositely charged ion from other reagent, that is Cl minus to form KCl. You have 2 moles here. Chromium +6 to +3. So +3, Cr +3 combines with Cl minus provided by HCl. So what I will get? CrCl3, Cr +3, Cl minus. What I will get? CrCl3. You have to know to which oxidation state it will undergo reduction, right? Next, the hydrogen should be removed as water. 2 chloride ions. Here you have 2 chromium, so I will write 2 here. Now chromiums are balanced. 2 chloride ions, 2 into 3, 6 chloride ions. 6 plus 2, 8 HCl. I will get 8 HCl. Alright. So hydrogen should be removed as water. So 8 hydrogen means 4 H2O. From where you will get these oxygens? So from here, out of 7 nascent oxygen, 4 are removed as water. Left over will be 3 nascent oxygen. So the released nascent oxygen can further oxidize HCl. So HCl plus nascent oxygen, how many? 3. So what it will do? It will combine with hydrogen to form water. How many water molecules? To balance 3 nascent oxygen means 3 water molecules. 3 into 2, 6 hydrogens we require. So we have to take 6 moles of HCl, therefore I will get 3 moles of Cl2. So the overall reaction is K2Cr2O7 plus 14 HCl gives 2 KCl, 2 chromium chloride, green color, the color change is also important, plus 7H2O plus 3Cl2. So if I assign the oxidation state, chromium plus 6, 2 plus 3, chlorine minus 1 to 0, minus 1 to 0. No, see, out of 14 chloride ions, how many are converted into chlorine atoms? 6. Out of 14, 6 are oxidized, converted into chlorine atoms. So remaining 8 remains as such. 2 into 3, 6 chloride ions plus 2 chloride ions, total 8 chloride ions remains as such. So 1 mole can oxidize 6 chloride ions to chlorine atoms, or 3 moles of chlorine molecules. Now from these two reactions, where we use this KMnO4 and dichromate, the titrations we call them as permanganometry, dichromatry titrations. When you use them as reagents for titration as oxidizing agent, right, generally those reactions are carried out in acidic medium. But if to maintain the acidic medium, if I use HCl, then instead of reacting with the titrant, it also react with HCl. Therefore, we should not use KMnO4, K2Cr2O7 as oxidizing agent if the acidic medium is HCl. If it is H2SO4, you can use, because in H2SO4 sulfur is already present in its higher oxidation state, it cannot be oxidized. But if it is HCl, then I cannot use KMnO4, K2Cr2O7, particularly in quantitative analysis, permanganometry and dichrometry. To maintain acidic medium, you should not use HCl. If HCl is used, some part of the oxidizing agent will react with HCl. The next reagent is bleaching powder. CaOCl2 reacts with HCl. Same procedure, what we get is calcium chloride plus water plus chlorine. So take 2 HCl, minus 1 to 0. Next, sodium hypochlorite, NaOCl. So NaCl is formed plus water is formed and chlorine you will get. Right. So one more we have is oxides of lead. We can use oxides of lead like PbO2 plus HCl, PbCl2 plus water plus chlorine, 2H2O, 4HCl. So lead changes from plus 4 to plus 2, minus 1 to 0. Out of chloride ions, 2 are reduced. Or I can use red lead, that is Pb3O4HCl. So oxygens are removed as water, 4 water, therefore 8 HCl. What we get is 3 PbCl2 plus 2 is the stable oxidation state of lead. So this is what you will get. Sometimes even I can take salt of HCl, say NaCl, react with H2SO4. NaCl plus H2SO4, you will get sodium sulfate or sodium bisulfate and HCl. So again I can do this reaction. So I can add this oxidizing agent NaCl plus H2SO4, you will get HCl, because this is salt of strong base, strong acid. Strong acid is HCl, HCl is weaker acid than H2SO4, so HCl is liberated. So once I get HCl, that can be allowed to react with MnO2. The oxide is sodium bisulfate plus manganese sulfate and chlorine as well as water, because 2 plus 1 3 3H2SO4 2H2O, 2 oxygens, 2 H2O. So these are the lab methods, right, for the preparation of chlorine. So let us study industrial methods. Let us study the industrial methods. Now coming to industrial methods, the first one is decons process. So what happens in decons process? HCl is oxidized with air. HCl is oxidized with air or oxygen in the presence of CuCl2. CuCl2 is a catalyst. So what we get here is chlorine and water. So 2 oxygens, 2 H2O, therefore 4 HCl, 2 Cl2. So the important question is, what is the catalyst used in decons process? Answer is CuCl2, cupric chloride. Let us see the mechanism. So this is important bit, catalyst used. The first step is CuCl2, 2 moles undergoes decomposition to give Cu2Cl2 plus chlorine. So we will get chlorine from the catalyst itself. In the second step, it will be again oxidized in the presence of oxygen to form Cu2OCl2. Oxychloride is formed, metal oxychloride is formed, which decomposes in the presence of HCl, right? We have to remove the oxygen, so we require HCl to give CuCl2 plus H2O. One oxygen, right? Alright. 4, 2 plus 2, 4, right. So again you will get back the catalyst. So the important point is, what is the catalyst used in decons process? Answer is CuCl2, cupric chloride. So coming to the next process, that is Weldon's process. Weldon's process. So what happens in Weldon's process? Here we take oxidizing agent MnO2, allow it to react with HCl to form MnCl2 plus water and chlorine gas. 2 oxygens, so 2 H2O, so we require 4 HCl, right. So the byproduct form, MnCl2 is the byproduct form. It can be reused instead of taking fresh MnO2. So we can generate MnO2 or a better oxidizing agent from MnCl2. Once again, in this process, MnCl2 is the byproduct. we are going to study how to use this byproduct to convert back into catalyst. So the MnCl2 that is formed is treated with lime, that is nothing but calcium hydroxide, converting it into manganese hydroxide and calcium chloride. This manganese hydroxide is treated with if I say water, manganese oxide, right? On heating, let us see what we get is MnO2 plus H2O, 2 hydrogens, 2 H2O, 2 oxygen, so it is not balanced. If I take 2 here, 2 MnO2, 2 H2O, 4 hydrogens, 2 plus 2, 4. Let us write oxygen here. These are 4, 5, 6. These are 4, 5, 6. 2 into 2, 4 hydrogens. Right. So it is oxidized in the presence of air to 2 MnO2. That is our oxidizing agent. Let us see one. Let us check once again. 2 manganese, 2 manganese. Here we have 2 oxygens. 2 into 2 moles, 4 plus 2, 6 oxygen atoms. 2 into 2, 4 plus 2, 6 oxygen atoms. 2 into 2, 4 hydrogens. I have 2 into 2, 4 hydrogens. It is balanced. So if I add excess lime, the further reaction may take place with manganese dioxide forming CaMnO3 and water. 2 hydrogens, 2 H2O, 2 plus 3, 5, 2 plus 4 hydrogens, 2 calcium atoms, 2 manganese, 2 to the 4, 2 to the 4, 8, 2 to the 6, right? It is balanced. So this is called calcium magnetate. This is also important bit, called as Weldon's mud. This can also be used as oxidizing agent. So what we are studying here is in Weldon's process, we are treating HCl with manganese dioxide. So we know that chlorine is released, right? The byproduct form is converted into oxidizing agent again by treating with excess lime followed by aerial oxidation, right? You can also use calcium manganate or Weldon's mud to oxidize HCl. You will get CaCl2, MnCl2 and water. So what is Weldon's mud, what is calcium manganate, these are important points, and how to convert MnCl2 into oxidizing agent. The next method is